Hi class, we have the 16th class for logarithms. The question is to express x in terms of y without involving logarithm. Express x in terms of y means find the value of y. Sorry, express x in terms of y means find the value of x. But on the other side, there must involve y. So this is expressing x in terms of y. So without logarithm means the final answer must have no log. That is all we want. All right, so the first one says log x base 2 plus log plus 2 equal to 2 log y base 2. Yeah, before we consider expressing x in terms of y, the first target here is primarily is to eliminate logarithms, the logs. All right, here is log, no log is here, here is a log. So what do we do exactly? All right, there are two ways to do it. Yeah, you can collect those with logarithm and those without logarithm, you go to the other side. So those with logarithm, we try to unify to have just one log. Then later you can do how to convert from logarithm to exponential. Or if you want, you can, the one without a log, you can give it a log. Now, bringing this one here, this goes to the other side. That one is somehow easy for most students that have gone through logarithm. But for the sake of beginners, let us give this one a log so you can learn something from that. So we say log x base 2. How can we make a single number to become log? What we do is we say log. Now it depends the base. The base here is 2, the base here is 2. So it has to get again base 2. Not because it is 2, but because the base here is 2. Even if here is 5, 10, or 3, or whatsoever, the base is 2, the base is 2. So the new one coming has base 2, has the number 2 again. So if this is base 3, we say log 3 base 3. Base 5, we say log 5 base 5. And the number itself is now acting as the power. Why is this one is true? Because if this number gets to the left hand side, it will become 2 log 2 base 2. And log 2 base 2 is 1. Why? The logarithm of any number to the base of the same number is 1. So therefore, 2 times this 1 is just 2, which is this one. All right. So this is log y base 2. This one gets to the top here. So we say log x base 2 plus log 2 squared is 4 base 2 equal to log y squared base 2. Yeah. If it's in a situation wherein one log equals to one log, or simply one term equals to one term, being that the bases are the same, we can just ignore them. But here are two terms. So let us try to have one here. Base 2, look at base 2. Because of addition, you multiply. X times 4 is 4x, which is equal to log y squared base 2. Yeah, one term, one term. 1 log base 2, 1 log base 2. So we drop the log. So what remains? 4x is equal to y squared. I hope it is clear. So, but the thing is to make x the subject, express x. So we divide here by 4, divide by 4. So this takes away this. So our x is equal to y squared over 4, or simply 1/4 y squared. So this is expressing x in terms of y without involving logarithm. If you want to copy, pause the video, then copy. So let's go for the second problem. The second one says 1 plus log x base 3 equal to log y base 27. All right, the previous one, the number that was there without log, we converted it to become log. So this again, we can convert it to become what? To become log. Okay. But making this one to become log is not the case here. The case is, even if we give it base 3, but this is not base 3. Yeah, but let's find out and see what is coming. So we say this one we want to convert it to logarithm. So what we do is, but which base do we use? Can we use 27? Let's use 3 because it is on the same side with this one here. So we say 3, 3. This is how we convert a number that is not in log to logarithmic form, a single number. And the number itself is serving as the power. So plus log x base 3 equal to log y base 27. So now we say log 3 to the power 1 is 3 base 3, log x base 3, log y base 27. Same base, we'll take 1. Yeah, same base, we'll take 1. So if we take 1, what do? We have base 3. For addition, we multiply 3 times x, 3x, which is log y base 27. Yes, it is 1 log, but the bases are not the same. So we cannot simply ignore what? We cannot simply ignore, how do I call it? The log, because they are not of the same. So we need to do something here. What is that? Here is log 3x base 3. Here is log y base 27. So let us generate base 3 here. So we say log 3x base 3 equal to, yeah, we need the same because the thing is, without involving log, we don't want to see log, but the base are not the same. So we cannot say the log cancel the log. It's not happening here. So how do? We go to change of base. Yeah, change of base, we have two formats, but we don't go to the one with 1 over. We go with what? The full fractional concept. So we say log. So this log takes this y. This log takes this 27. So you and I can choose any base we want as long as that base obeys the logarithmic rule, the logarithmic concept, wherein the base cannot be 0. It has to be greater, positive. Okay. So in that case, not even 1. In that case, since you and I can choose a base, so the only base we can accept is the one here. So we can say base 3, base 3. I just hope this one is understood. Okay, so if that be the case, this is log 3x base 3 equal to log y base 3 over, how about log 27 base 3? If someone who has gone so far with logarithm, you can look at this 27 and say it is 3 to the power 3. If 3 to the power 3 comes here, it becomes 3 log 3 base 3. Log 3 base 3 is 1. 1 times 3 is 3, so the denominator will just become 3. But beginners will not see all that one quietly. So we say log 27 means 3 to the power 3, and this is base 3. So log 3x base 3 log y base 3 for the one at the top. This 3 comes here, so it becomes 3 log 3 base 3. So log 3x base 3 equal to log y base 3, the one at the top. So this is 3. Log 3 base 3 is 1. Log of any number to the base of the same number is 1. So therefore, we'll say log 3x base 3 equal to, at the top, still log y base 3. 3 times 1 is 3. Yeah. So what happens here? This one has 1 as a denominator. So if we cross multiply, what do you think will happen? This 3 multiplies this one multiplies this. So if this 3 multiply this, what do we get? We'll get 3 log 3x base 3. 1 times this one becomes log y base 3. Can we cancel the log now? Not yet, because there is something in front here. This one has to move to the top. Yeah. So please, this one is for you. So try and tell me what you have in the comment section. Okay. So if this one goes to the top, we have log 3x to the power 3. If it's just x, no need for the brackets. But 3x, so base 3 equal to log y base 3. So now, one log, one term, the base are the same. So we drop the log. So we say 3x to the power 3 equal to y. 3 to the power 3 is 27. X cubed equals to what? Y. Is this our final answer? No, because the question is express x in terms of y. Yes, so divide here by 27. So x cubed equal to y over 27. Is this our final answer? No, because we want x to stand alone. So in that case, we ignore the cube, then the other side becomes the cube root of y over 27. Y cannot give us a single value for cube root, but 27 can give us a single value. So the one that cannot give us a single value for cube root, it remains a cube root. So say cube root of y. How about cube root of 27? Is 3. So this is expressing what? X in terms of y without involving logarithm. Thank you for watching. Don't forget to follow, like, share, and comment. Also subscribe to the YouTube channel. See you in my next video.